Hi everyone, in this video we're going to be evaluating piecewise functions. So to evaluate a piecewise function, we're going to have two steps. We're going to determine which domain includes our given input value, and then we're going to plug that input value into the expression and evaluate. So in example 1, we have the piecewise function g of x. So I have x squared plus 2x plus 1 if x is less than or equal to negative 2. And then I have 1 minus x squared if x is greater than negative 2. So we have our first one right here where we have an input value of negative 3. So we need to be able to determine, does negative 3 fall in the domain of x is less than or equal to negative 2 or x being greater than negative 2? Well, negative 3 is less than negative 2. So it's going to go into this first equation. So what that means is we're going to take that first equation, and anywhere there's an x, we are going to plug in negative 3. So I have negative 3 squared plus 2 times negative 3. And then we are going to type that into our calculator to evaluate. And no, you don't have to use a calculator. You can do this by hand. So if we did it by hand, we would get negative 3 squared, which is 9. 2 times negative 3, which is negative 6, plus 1. So that would be 9 minus 6, which is 3, plus 1, which is 4. Next one, we see that we have an input value of 0. So we need to determine where 0 falls. Is 0 less than negative 2? Or is it greater than negative 2? And this one is going to be greater than negative 2. So we're going to plug in 0 into that second equation. And it looks something like this. So when I plug 0 in, I get 1 minus 0 squared, which is 0. And I just get 1. And that would be my answer. The next one. Go ahead and you try this one, see how you do. So this one, we needed to plug in negative 2. Well, we need to know where negative 2 is going to fall. That's only going to fall when it's equal to right here. So that means it's going into the first equation. So I'm going to plug in negative 2 anywhere there's an x in that first equation. And that would give me 4 minus 4 plus 1, which is just equal to 1. So looking at our second example, go ahead and pause the video and try these 3 on your own and see how you do. Okay, so when we're looking at this first one is negative 3. Negative 3 is going to fall into this domain right here, or this equation. So we're going to plug in negative 3. Be careful with your parentheses, making sure that when you're plugging this in for x, you are putting parentheses around it. So we have negative 3 times, in parentheses, negative 3 squared plus 1. So if we look at this, negative 3 squared is 9. So I have negative 3 on the outside, and then I have 9 plus 1. That would be 10. 10 times negative 3 is a negative 30. Looking at the next one, we want to know when x is negative 2. So when x is negative 2, that again is that first equation. So you have to pay attention to where the equal sign is on it, and it's right here on that one. So I'm going to plug in negative 2 anywhere I see an x. So I have negative 2 times negative 2 squared plus 1. That would be negative 2 times 4 plus 1, which is 5. 5 times negative 2 is a negative 10. So again, we're just plugging it in, and hopefully you're getting these answers when you try it on your own. Now, on the last one, it says when x is 1. So we're looking on where 1 falls in our domain restriction. Well, if I look right here, 1 is not included because there's no or equal to. On the last one, 1 is also not included because there's no or equal to. So 1 actually does not fall into either or any of these domain restrictions. So this is going to be undefined because there's not an x value of 1 that falls into any of those domain restrictions. So sometimes that happens, but if it does have an equal sign to, you would plug it in just like we did in example B. Now the last part is doing the same thing, but with a graph. So as a reminder, the numbers inside the parentheses are the x values. What we're looking for is the y values. So sometimes writing that x right above that and y right there is helpful. So when x is -3, what's our y value? So we go to our graph at -3. Okay, and notice how I have an open circle and a closed circle. Well, when we're evaluating, we want the closed circle, so we don't want that open circle. So we want that y value with the closed circle, which is just 1. Now, when x is 1, what do we have? So when x is 1, here's 1 right there. Again, it has an open circle and a closed circle. We do not want the open circle. That's the hole in the graph. So we want the y value at that closed circle, which is 6. Then I look at -5. -5 is directly on the line, so there's no second guessing that one. So that would be -3. So pause the video and try the last 3 on your own and see if we can get the same answers. So hopefully you gave it a try. On D, we have 3, which is right here. The y value that goes with it, no second guessing because that's the only one, is -4. At 7, we're right here. And again, that's the only part, so it should be 0. At -1, I'm right here on this line. So my y value should be 6. So if you have any questions over any of this, please make sure you write them down and you ask in class.